Hi, I'm Miss H, and today we're going to be talking about atoms. You probably already know that atoms are what make up everything that exists. Atoms are the smallest particles of matter that still maintain the properties of the element. This means that a single atom of copper would have all of the same properties as a copper wire does. We call the center of the atom the nucleus. Nucleus means center. The nucleus is small and positively charged. If you were to take an atom and make it into the size of a baseball field, the nucleus would only be the size of a marble. Most of the mass of an atom is located within the nucleus. Surrounding the nucleus is an electron cloud with multiple energy levels, or orbitals. All atoms contain 3 subatomic particles. You've probably heard these names before. Our 3 subatomic particles are protons, neutrons, and electrons. Protons are located inside the nucleus. As the symbol suggests, protons have a positive charge, and they have a mass of 1 atomic mass unit, or AMU. We use an atomic mass unit because any other form of mass would just be too large, such as grams. Our next subatomic particles are our neutrons. They are also located inside the nucleus. As the name neutron implies, these are neutral, which means that they have no charge. They also have a mass of 1 AMU. Finally, our electrons surround the nucleus. Electrons, as the symbol shows, have a negative 1 charge. Electrons have a mass that is so small that we consider it to be 0. Although they do have a mass, because they have to in order to exist, it's so small, so much smaller than that of a proton or a neutron, we don't have to actually think about it when calculating the mass of an atom. The number of protons that an atom contains is what identifies which element that atom is of. So for instance, if we know that an atom has 6 protons, we know that that atom is carbon. All atoms are neutral, which means that they have no charge, so that means that our number of positives and negatives must be equal to one another. This means that we know that our number of protons and our number of electrons are going to be the same. Since protons and neutrons are what are located inside the nucleus, and each of them have a mass of 1 AMU, we can total those up to find out what the mass of the atom is. Because the outermost energy level is so important in how atoms interact with one another, we give it a special name, and we call it the valence energy level. The electrons that are found on this energy level are also called valence electrons. One of the ways that we use to represent atoms is a Bohr model. Bohr models are very simplified versions of what the atom looks like. They are used to help us see how atoms look and interact in a manner that is easier than a proper model would look. Just as in the atom, we represent in a Bohr model the nucleus with the protons and the neutrons, and we draw circles to represent the energy levels that surround the nucleus. Within these circles, we represent the electrons as dots. The first energy level of an atom can hold 2 electrons. The second energy level can hold 8 electrons. And the third energy level can hold 16 electrons. For our class, we will never go beyond number 18 on the periodic table, so we will never need anything that has more than 8 valence electrons and never need to go beyond the third energy level. Let's take a look at a couple of Bohr models. We're going to start with sodium. What you see here is what you would see if you looked up sodium on the periodic table. The number at the top of the box is the identity of the element, which we said before is the number of protons. So in this case, sodium has 11 protons. Since atoms are neutral, that means our protons and electrons must be equal, so sodium also has 11 electrons. The number at the bottom tells you what the mass is. Because it's impossible to have a partial proton or a partial neutron within an atom, we round this off to the nearest whole number, which would be 23. To find our neutrons, we take this 23 and subtract the 11 protons from it, and that gives us 12 neutrons. To begin our Bohr model, we start with a circle. Now, in a Bohr model, we make the nucleus much larger than it is in a real atom to make it easier to see. We write our symbol for protons and how many we have. We write our symbol for neutrons and how many we have. Then we draw a circle around it to represent the first energy level. Our first energy level can only hold 2 electrons. I draw my 2 dots here to represent my 2 electrons. Now, it's not important where they were on the circle, just that I don't put more than 2 on it. Since I need to have 11 electrons, this means I need to add another energy level. Remember that our second energy level can hold up to 8 electrons. Again, where the dots are drawn is not important. It's just important that we include the right number. I like to draw them this way because putting them in pairs makes them easier to count. If I count how many electrons I currently have, 2, 4, 6, 8, 10, I see that I'm still short by 1 electron. Since this energy level is full, I add another one, and I put a dot on it. I now have 11 electrons, so I now have a proper Bohr model for sodium. Let's try another one, and this time we're going to move to the other side of the table. Let's look at oxygen. Again, to find out the identity of oxygen, we have 8 protons. It came from up here. Since our atom is neutral, we have to also have 8 electrons. This one is already a whole number, so we don't have to round it. 16 minus 8 gives us 8 again. We start with our nucleus. Again, this nucleus is much larger than in a real atom. It's just there to make it easier to read. We have 8 protons. We have 8 neutrons. We add our first energy level. We can put 2 electrons in this energy level, but I need to have 8 electrons, so I need to add another energy level. 8 minus 2 is 6, so I'm going to put 6 electrons in this energy level. And I now have a proper Bohr model for oxygen. You can be able to draw Bohr models for any of the first 18, or really actually the first 20 elements, based off of the information in this video. As always, if you have any questions, please feel free to send me an email.